obviously I'm Jack Cook, and I'm one of the G4C Northwest committee members, and I'm also an estimator who works for F.Parkinson. Obviously, just a brief about myself. Obviously, I'll be hosting the webinar today. Obviously, in today's webinar, there's going to be obviously a couple of projects that we're going to talk about. So the first one's going to be about the St Helens Community Fire Station from Wates, and then also we're going to talk about Kier's Shakespeare North Playhouse scheme. But obviously, people who don't know what G4C is, obviously we're a young professional voice of the UK built environment. So we're an organisation that's set up to try and give obviously the next generation and the younger generations of our industry a chance to obviously try and inspire the next generation that are coming through. Also try and give them a voice, because obviously sometimes they might struggle to have a voice to try and obviously give their views on how the industry needs to strive forward and changes and stuff like that. Obviously we try and do different webinars and blogs and talks around varying different events. So that's really what G4C is. Obviously we've decided to do this webinar series because obviously in the lockdown period, we did a national conference with all the G4C regions where we decided to discuss some of the things which we feel our industry needs to change or strive for a change. And our team decided that one of the things that we needed to try and improve was communication, because we thought sometimes people get siloed in their industry or their job and probably don't understand what's going on maybe around them or what other people are doing. So obviously we tried to come up with this webinar series, try and open a communication line to show what's going on around the Northwest and what other people are doing, and obviously try and give people like similar experience to us or people who don't normally have a chance to talk about their project, a chance to talk about it really, to be honest. So obviously recording this, so I'd like everyone could use themselves, so obviously the speakers can obviously speak efficiently about their project. So now I'd like to hand over to Peter and Jamie, who are going to talk about this project which Wates are doing at St Helens Community Fire Station.
Thanks, Jack. Thanks for the introduction. Welcome everybody. Thank you for the opportunity to discuss the project we've got here. It's definitely been an interesting 6 months for us. So it's fantastic to be able to be given the opportunity to discuss what we've been doing down here. So Kier, would you like to flip on to the next slide? So the project itself is a design and construction of a 2-storey, 3-bay fire accommodation and garage project. So we're located in St Helens. We're just off the Linkway. The project value is about £7 million. It's a 60-week programme. Included in the fire station project, we've got a training tower, which you can see at the back of the graphic there. So they've got all the everything they need the fire station to do the training. They've got an open water tank. They've got the training tower, and it also includes all the FF&E. So it's a complete fit out that they basically turn up and they can use the fire station from day one. Would you like to move on to the next slide, Garrett? So one of the benefits of the project is the improved response times that the fire station will have. The project is a merger of 2 stations. So Eccleston and St Helens part is closing and moving into this one station. So this will become a super station in St Helens. It will save the fire service some money on year by year on the budget. It's going to be a fantastic new training facility for the fire brigade. And one of the key things of the project, one of the key benefits is there's only so much green space in the country for us to build on. So being a regeneration brownfield project, we're actually taking some of the industrial legacy from previous years and making a fantastic building. And we'll touch on that as we go through. So just to introduce Pete and myself, I'm a project manager for Wates. I've been with Wates for about 7 years. I've graduated with a construction management degree, did some A-levels with maths, physics, chemistry. I used to love my sciences, and I really enjoy working outdoors, especially when the weather's been as good as we've had this summer. And previously with Wates, I've won the Mentor of the Year by Career Ready in 2018. So that was supporting students from Salford City College Went down to London to pick up the award, and it was amazing, some of the stories of how we changed the lives of young people, and that's one of the key things that Wates do. So because of that, Pete, who sat next to me, socially distanced 2 meters apart, is one of our production management trainees. He's going to introduce himself now.
Yeah, so myself, like Jamie said, I'm a production management trainee. I've been with Wates now for just approaching 2 years. Been on a couple of projects, a couple of schools. This is my first fire station, and I've been down on this project now for about 3 or 4 months, helping Jamie out as we get towards the finishing stages. And it's been Jamie's been passing knowledge on to me and helping me develop as part of the scheme. So next slide, please. Just as the slides get in there, I think a little bit of background on Wates, just for anyone who's not aware of what Wates do as a company. So we're the UK's largest privately owned construction firm. We're a family-owned business. We've got roughly 4,000 employees. And I think Jamie will agree with me. I think through the pandemic, being family-owned, you can really feel that kind of, they do care about us and they do try to look after us. It's been really useful to keep us delivering this project. So, next slide, please. And just in terms of Wates' overall vision, so what we're trying to achieve as a company, we're trying to build a sustainable £2 billion business across the construction, property services and development sectors. And we aim to deliver on time, on budget and to a good quality every time. So we'll move now into a bit more detail on the actual project here at St Helens. So you can go on to the next one, Kier, as well.
So in the northwest of England, we've got a construction business who we're part of, and some of the projects that we've developed, we've done strategic warehouses, we've done accommodation houses, we've done student accommodation, we've done retail with cinemas thrown into it down at Bedrock. We've done leisure centres, we've also done schools, so we have a real mix of businesses. So this project is the fourth in partnership with Mersey Fire and Rescue. It's the third fire station, and also we're assisting with Cheshire Fire Service as well with some of the projects down in around the Warrington area. So we've got a real strength. We're working on blue light projects, and that's where this project has taken us. If you can swap on to the next slide, Kiara. So apologies for the link asking Kiara to sign it. With our a couple of technical difficulties on the sound on the video later. So the location plan where we're based just off the Linkway, as I said. We're in the back door of Pilkington's. So it used to be an old glass furnace. It's quite a huge industrial heritage in St Helens, and if anybody knows the local area, there's been industrial coal mining and glass making on here for hundreds of years. So if you can go to the next slide, Kiara. As a construction company, St Helens is a fantastic place to work because it's got good traffic links for around the region. So the map that you can see on your screen at the moment is from around about the 1880s, 1890s. So if you see on the top right of the screen, there's the St Helens Canal, and you can see in the middle of the screen is the St Helens Colliery. So our project is based on top of an old mine shaft sort of area where they're digging out all the coal. And one of the spoil pits. You can see where the train lines go. So the train line that runs through from bottom left to top right is still in existence, and that takes people from St Helens into Liverpool Lime Street. If you can go on to the next slide, Kiara. So when we were working through the project into the basement, and I'll show you some photos later, we were finding some old train lines, and I was wondering where are all these train lines coming from? And as you look on the slide, you can see that as the project's been developed, over the years with Pilkinson's and the other sort of tenants and residents that have been here, they reuse some of these train tracks in the actual build. So as you move on to the 1920s, Pilkinson's have bought the land, and in the centre of the screen there, you can see like an L shape. That's a glass making furnace. So that's where they're making things like TV screens, car windows. One of the factories that's on here at the moment makes about 90% of the UK's production of bathroom glass. And that's still in existence. If you skip on to the next slide, please, Garrett. So the red markings that are outlining on top of the factory, so that factory is where they made the glass. the red line is our site boundary. So before we took over on the project, the factory was demolished. And within that, because it was adapted from about the 1920s up until about the 1990s, I think they had experimental furnaces on the project. You can imagine that the technology for buildings with asbestos roofs and asbestos coatings onto steel was paramount. Also in the glass making industry, there's contamination as well that they use in the process. So a real mixed bag. And again, I'll show you some demonstration of that as we go through the slides. You'd like to go on to the next slide, Kiara? So this is the site layout. So you can see with the main building is with the appliance bay with the engine house attached to it, and then at the top of the project there you can see the garage where they've got the CPL is going to be stored. And a couple of things to note on the drawing is the blue hatched line that comes through. There's a couple of high pressure gas mains that run across the entrance to the site. And also you might be wondering what the circles are. Well, I'll come to the circles on a later slide. If you'd like to skip forward, Kiara. So some of the top 5 key risks that we had on the project were the treatment to the existing ground and finding a suitable engineered foundation solution when there's potential mine workings under the project and unknown voids based on the furnaces for the glass making process. So we touched on the mine shafts. So the circles on the drawing that you saw were potential mine shaft locations that were reported by the Coal Authority. St. Helens has had years and years and years of coal workings on the site. Existing services, so high pressure gas mains that feed half of St. Helens, understanding a safe method of working around that and bringing in our drainage that crosses these pipes. And also due to the industrial heritage, the existing ground environmental conditions, and how we're going to make sure that we don't contaminate St. Helens, our workforce, anybody in the future that's going to be occupying the building, and coming up with a remediation strategy that satisfies the Contaminated Land Officer and the EA. And then finally is ensuring that we've got incoming services that will run the building for years to come. So we'd like to skip on to the next slide, Kiara. So the next slide shows the potential targets that the Coal Authority had. So as years have gone by, they've got documents that record where potential mine shafts are. So these are coordinates. So before we actually built the building, we had to try and probe and find these mine shafts. So thankfully, we didn't locate any mine shafts under or around the perimeter of the site. So that was good for us in terms of we didn't have to dig down and cap off the mine shafts. But it's quite an involved process of using a rotary drilling rig to put some probes in the ground and try and find them. Potentially one of the shafts could have been about 450 meters deep. So it gives you a flavour of what we were trying to find on the actual site boundary. If you'd like to skip on, Kiara. One of the key things to know about the project as well is that F.Parkinson's is still in operation. So we've got the railway sidings where they bring the sand into the factories, and that goes off and gets made into the float glass, which is on the site just neighbouring to us. For the consultants, we've got a fantastic team supporting us on site. So Ryder Architecture, Curtains Engineering have produced the structure and the fabric design. In the ground, because it's specialist engineering advice, we spoke to our Wates technical services and dealt with a company called Byland Engineering at Idle-Meerbrook for the site validation. M&E, we're using A&B Engineering, which are based in Liverpool, which is another key part of our strategy on the project. And also for the Northwest Construction Hub is that we use and employ local contractors to carry out the work. The M&E was peer reviewed by Davis and Partners and also CAD 21. And the Cadent gas, where we were crossing the high pressure gas main, that was reviewed by Cadent and a company called DMVGL. If you'd like to move on to the next slide, please, Kiara. So Byland Engineering, a ground technical specialist, ground engineering technical specialist. So they looked at the key risks and the features of the project, and we looked at, was the ground suitable for piling? Was the ground suitable for mass fill concrete pad foundations? So I think what they looked at is because we had unknown voids and we had unknown obstacles potentially in the ground, that the best way of looking at the project was to excavate all the unknowns in the ground, all the voids, put the material to one side, crush the material, and then have a 4 or 5 meter deep foundation that was an engineered fill, and then we could do a raft slab foundation on top of the engineered fill. So the engineered fill was placed back in about 200 millimeter layers at about 4 or 5 meters down, and every layer had to be tested. And that was what Helens provided to us. They provided the specification for us to meet. If you'd like to go on to the next slide, Kiara. So on the next slide, you can see the photographs of when we took over the project, and I'll quickly skip through these photos. So you can see the various levels where the experimental furnace was on the left-hand side. On the right-hand side is a flat concrete, but underneath the flat concrete was various voids. So if you go to the next photo slide, so what we had to do is try and work out a safe methodology for the machinery to drive around the site without collapsing into any of these voids. So we use techniques like buried services, survey scanning, GPR, trying to work out if there's any voids, core drilling the slabs to work out if there's any voids, and using a bit of knowledge from Pilkington's. And you can see the amount of steel that's there on the left, and the brickwork and all the existing structures in the ground on the right-hand side. If you go to the next slide, Kara. The next slide shows you where you've got the machinery breaking out all the concrete and all the attachments, the demolition hammers, the grabs, all the machines had various jobs to do as we worked through. So all that had to be sequenced, and you can see the big moxie there on the right-hand side where all the crushed material got loaded up into the moxie to drive around to the storage area where the materials would be crushed. If you go to the next slide, Kiara. So the crushed concrete, the crushed brick, it was all tested. And that was then formed into the basement. One of the couple of the interesting slides that you can see there is the black staining that you can see on the ground is actually flues. So if anybody's been to St. Helens, they've got chimneys. So all the hot gases from the furnace process went through the flues, and that was taking the hot gases back up to the chimney. On the right-hand side where you can see the yellow arrow, that's like a honeycomb structure. So the honeycomb structure is designed so it takes more heat out of the flue gases. If you'd like to skip on to the next photo. On the next slide, you'll see a couple more of the flues, and you can see the extent of the basement excavation. We were excavating all the material to get down to a competent layer. Once we got down to the competent layer, we then carried out more testing. But you can see the blue on the left-hand side, that somebody's had to form that in the 1920s or 1930s to take. So when you look at buildings, you always think of the people that actually built them. And I think there was a brick making works actually on the site when they're developing Pilkingtons. So if you'd like to skip to the next photo. So again, you can see the testing going on when we got down to the lower level. So it was dynamic probe, super heavy testing. There was borehole testing, geophone testing, which meant you had to stop all the plant on site where they were putting waves through the ground. And on the right-hand side, you can see us actually rolling in 200 millimeter layers material which have been tested. If you'd like to skip to the next slide. So just as a figure for you, on site, we've crushed about 14,000 meters cubed of material of various concrete and brick. There was about 200 tons of steel that came out of the basement voids. And that little gadget on the right-hand side is an NDM tester. That piece of kit is worth value of about £16,000, and that has to be calibrated. So it takes about 3 or 4 weeks to calibrate that based on various tests that we do that drive the spike in the ground, and that tells you whether you've achieved the right compaction and the right moisture content on the layer that you're working on. And that's all then goes into the validation report for the foundations of the building. I'd like to go on to the next slide. So for those of you that are a bit more interested, there is a case study on the Northwest Construction Hub website. So you can actually click on the website, and there's a document there that shows some of the other photos that we've got, some of the flues where they were taking the gases to the chimneys. So that photo on the left, it was fantastic. I think that was a cullet that came off one of the machines. So in the glass making process, they used to put 10–15% of waste glass back into the glass. We were finding big lumps of glass boulders on site, loads of things from the heritage of making the project. And you can see all the old flues on the case study. If you'd like to skip on to the next one. So for the next slide, one of the benefits of working in construction is we work in all weathers. So we worked through the winter, and I think it's been one of the wettest Februaries on record, but the civil engineering team have managed to work in such a sequence that we didn't stop for work. We didn't have any downtime in February at all. And you can see on the right-hand side that the way that the site has been set up, there's space and availability for the machines to work. So it's all about keeping people and the machines separated. The little picture in the bottom there, that was the slab settling analysis that we got from Byland Engineering. So for those of you that are looking at different careers in the industry, it's not just about driving machines or bricklayers, which are important to us. There's also a lot of work goes on from various consultants, designers, and engineers. So if you'd like to go to the next slide. So you can see the second best building in St Helens in the distance. Obviously, ours is the best. St Helens are the champions at the moment for the Super League. But you can see the development in the area. So on the right-hand side, where the retail part was an old colliery. Our building was based on a colliery, and then you can see the development, how things have changed. And there's future development in St Helens on the top right of the photo. Okay, if you'd like to go to the next slide. I spoke briefly about the Cadent gas main, and again, you can read through the slides later on if these are saved onto the system. Within Cadent, if you skip to the next slide, we get a safety guidance from Cadent that you're not allowed to work within 3 meters of any pipeline without a site inspector on site. We had to carry out a surf load analysis to make sure wagons crossing the pipeline wouldn't damage the pipeline, and you get a specification for working within that 3 meter easement. And on the right hand side, we engaged with Cadent. We had the vacuum excavation unit. So anything working around services, just to make sure we don't damage the service with a bucket of a machine, using the Hoover attachment, is a way of not damaging the pipeline. So we'd like to go to the next slide. And again, we touched on the environmental control. So being a brownfield site, we had asbestos management plan in place. We had daily air monitoring. We had the guys trained up on site in asbestos works. We had full-time air monitoring. We had a full-time analyst on site, sort of checking anything that was discovered. We had asbestos contractor on site, just picking through any materials to make sure that we were capturing and monitoring the contamination that possibly could be within the site. And again, all of that was supplemented by a material management plan, a remediation strategy, and we had the St Helens Contaminated Land officers to site as well to make sure that everything we were doing was best practice and in accordance with the national regulations. I'd like to go to the next slide.
For this one, I'll try and do a nice brief overview of the kind of construction process of the building as we move towards a finished building. So this is just an overview of that we do use BIM modelling at Wates, and we've used it on this project. You can research it further. I won't go into too much detail, but it's useful for finding clash detection. But if you're looking at kind of steel work and M&E services, so we have used it. So next slide, please. So the building itself, again, you can see on the 3D modeling here that it's a steel frame. So benefit of the 3D model, we can really see how it is going to look and how we can kind of plan our services, plan the finishes, and plan how we're going to actually approach the build. So next slide, please. And then we can now look at kind of the actual construction process. So the next photo that you see coming up on the screen, you can see the plastic holding bolts, where we've then gone and laid the concrete slab and laid the foundations of the building.
Yes, but for the holding down bolts there, we're using plastic cones, so that protects the concrete actually going into the holding down bolt. So you can see the holding down bolts where the steel frame goes and the reinforcement on the slab. So the slab we've got is about 750 mil thick brass slab on top of all the re-engineered fill in the ground.
Yeah, if you move on to the next slide, Kira. So a couple of photos just to see the process. So we've got a 60-ton crane that you're going to see on the left-hand side is what we erected the steel work with here. You can see the steel frame going up, which is the kind of basis for the structure of the building. If you move on to the next slide, you can see we've got quite a detailed logistics plan for the project. The reason for that, we have some quite complex groundworks, as Jamie's touched on before, quite complex civils work. So having kind of an in-depth plan of how we can approach the building, where we can access or we can't access, has been really useful throughout the build. So you move on to the next slide. The next couple of photos will show you kind of the envelope of the building. So you can see the insulation on the right-hand side. You've got your secondary steel support. We'll touch more on the facade in a couple of the slides coming up. So if you go to the next slide, you can see the floor plans here at the top. So I'll just say it's a fantastic new facility, as mentioned, and it's really making the most of a brownfield site. So on the bottom there, we've got a flat roofing system. It's a Mach 1 system. It's a combination on the facade of brickwork and cladding. A couple of photos coming up. We passed the air test first time, so it's a good quality build, and it should produce a highly energy efficient building. So if you go to the next slide for me, Kira. I think we'll skip over the video just now, but there is a video sort of tour of site, so you can have a look kind of at the finishes. We talked to a couple of things inside and external. So I think we're going to upload the PowerPoint anyway, so you can have a look yourself into that. So I'm going to touch on a few more things rather than do it just now.
Yeah, Jack, we're just mindful of time. I know where we are. So we'll skip on to a few more photos.
I'm just saying, obviously, with time, Matt, do you want to just play the video and then we might move on? Then obviously show it different. Might show something different. So yeah, if you just show the video for the last 5 minutes and then we can share the PowerPoint with everyone, if that's all right with you. Obviously, just to do with time.
Yeah, sure. Okay. Yeah, fine. You want to go back a slide and then you can you'll be able to show the video. I'm Jamie. I'm the project manager for the St. Helens Fire Station project. Back in the 1880s, the site was built on a colliery. It was an old coal mine, and then from 1920 onwards, there was an industrial factory on site that was making glass. What we've done is we've taken over the project when the factory was knocked down, and we've actually broken up all the concrete on site, crushed it up and used it in the foundations of the new building. By doing so, has meant that we've reduced the number of vehicles that are on the road, which has mean a more sustainable building and reduced the amount of diesel that we've actually burnt and polluted the atmosphere. So it's a clever way of using the historical past to make a future brighter for all of us. So the old map that we got from F.Parkinson's, who is our nearest neighbour, clearly shows all the industrial heritage from St. Helens. So in St. Helens, you'll notice that there's lots of chimneys poking out of the skyline. And what we've done is we've worked our way through all the ground, all the bases and all the footings of the chimneys, the flues and the glass that was in the ground, and delivered a fantastic new fire station for emergency fire and rescue.
Good morning. Welcome to St. Helens Fire Station. How can I help you today? Have you been here before? Due to COVID-19, we have got a procedure in place where once you're on site, we'd like you to wash your hands. If you give me a moment, I'll find out if you're supposed to be here or not, and I'll radio the team.
Perfect. Thank you very much.
Well,
this is a 20-ton JCB excavator. It's the biggest machine we've got on site here at the moment. The power that the hydraulics produce on this in turn, this was a brownfield site originally, and you've got huge excavations. This thing can produce, and the power it produces is immense. The reason we focus a lot on building walkways is that when you've got machines like this travelling around the site, there's potential for some high risk incidents. You've got to be careful when you are moving around. One of the things we like in construction is that we can use big toys like this. We always like using bigger and bigger machines. Go all the way up to the likes of this 20-ton excavation. So this is a lift, one of the many forms of high-level access equipment that we use on the project here at St Helens. At the moment we're using it to do our high-level services. We've got trunking running high level, we've got cables across, and we're looking at doing some high-level lighting. We've got high-level pipe work running across, and some high-level gas main running down the far side of the drying spur here, as you can see. Making good progress in here. We've got some finishing works on the thing. Just finishing work services across the pipe main on the far side, and we've got down the roofs on the other side of the room. So we're now standing where the kitchen is going to be fitted eventually. If we have a look up, you can see the importance of having secure fixings. So it works both ways. So down from the roof, you can see the screws coming through, holding down the roof out, the insulation. And the other way, with the force of gravity potentially bringing things down, you've got secure fixings. You've got secure to the purlin, which is the light metal you can see running across. Again, the whole unit's fixed back, so this whole unit's nice and secure. But one thing for me in construction that you don't always get to see when you go inside a finished building is what's behind walls and what's behind ceilings. So if we look at all of our internal walls here, so you can see you've got your plywood running down the wall. It's called a patras. We use that to fix something back, so you've got a more secure fixing in case something's got some weight to it. So lights on this one, we've got a sink unit going in here, which will be supported by the patras behind. You've got your conduit running down the wall, which will eventually turn into your sockets and your data points. Your cables will be pulled down from the ceiling. So where you've got any services, you've got your copper pipe work, you've got some conduits and cables coming to the wall here. It's important that we maintain separation between rooms, so that takes a form of fire stopping. So you can see the white bat that sits around it, designed with a fire rating. So if there is a fire in certain areas, it'll have a designated time before that fire spreads into different parts of the building. Typically that's 30 minutes, 60 minutes. On here it's 60 minutes between the walls. So now we're on the roof. So the roof system on here is we saw the fixings from beneath. You've got insulation, then you've got the mat 2 felt on top. So that's screwed down, held in. That's the importance of a flat roof. It needs to be weather tight. And then you've got rainwater, so when it does rain, the water will gather on the sides of the roof and go straight down all the way to ground, all the way through the drainage system. You've got vent pipes. You've got a roof light here as well. Again, important things on the roof to keep it weather tight, stop any water getting into the building below, and then you've got your lightning protection. So if the building does get hit by lightning, it's a connection straight down to the ground, prevents any risk of injury inside the building.
So just like to say thank you to obviously you two from Wates for obviously presenting that. We're a wonderful project and can't wait for it to get finished. So yeah, now I'd like to hand over to Natalie from Kier, who's going to talk about their scheme of Shakespeare Northern project.
Hi everyone. I'm dialing in from Cyprus today, so I do apologise if the connection's not great.
We're wonderful for you joining us, to be honest, really. Obviously, I know it's the beauty of probably technology, really, and we appreciate you taking time out of your holidays to obviously talk about your project. No problem
at all. Okay, so I'll share my screen, bear with me. Okay, can you see that? Yeah, okay.
Yeah, you see that.
Brilliant. Okay, so just to start off with, I'll just give you a bit of a quick sort of overview of myself. So I'm Natalie Lucas. I'm obviously from Kier. I'm an assistant design manager. I actually started my I studied architectural technology in Liverpool John Moores University. I came out and went straight into architecture. I worked for a few architect practices. The last practice I actually worked for was Ryder Architecture, and we actually worked with Wates to put the Prescott Fire Station together. So it's quite interesting to obviously see the previous presentation and see the similar sort of characteristics and things. So one of the things that I kind of enjoyed about my career as an architectural technologist was the close relationship that I had with contractors. We tend to obviously do a lot of the handover, a lot of the detailing, so you spend a lot of time on site, and it just sort of clicked in my head really, that I thought I kind of want to pursue a career more in the construction side of things as opposed to the architecture. And also having an appreciation for architecture, I thought it'd probably benefit me really moving into contracting with that kind of appreciation. So I joined Kier exactly 2 years today, and I've never looked back since really. I've really enjoyed my career so far as a design manager. It obviously has its ups and downs and things, but most of them are obviously ups. And I think it's just the fact that I finally found my calling anyway. So since I've been at Kier, I've worked on a school in Liverpool, Belvedere Academy, and I also now am part of the Shakespeare North Playhouse team. So I think what I'll do is I'll crack on with the presentation for Prescott. And let me see. Right, this should. So just a quick kind of introduction to how Kier got involved. We received the invitation to tender back in the summer of 2017 and were confirmed as preferred bidder in January 2018. The scheme was procured under the Northwest Construction Hub high value construct only framework. We believe the client chose this procurement route as a vehicle for ensuring Kier could tender the scheme. As we know, they were just really impressed with the work that Kier had done on the Chester Story House, and were keen to work with us on the back of that. So location and a bit of media coverage for you. So for some of you, you may have already seen a lot of the press coverage for Shakespeare. It's been on BBC One show. They've been on site a couple of times. It's Dame Judi Dench is actually a patron of the Shakespeare North. What I've provided here on the screen is just a couple of snippets of things that we found in the media, some interesting points. So Shakespeare Prescott is going to complete what they call the Shakespearean triangle, because we have the Globe, the Sam Wanamaker in London, we've got Stratford upon Avon, and now we've got Prescott. So I think as Dame Judi Dench has actually said, everyone in Britain should be able to follow a Shakespeare journey from London to Stratford and then to Knowsley. So in my experience, this is the first kind of Playhouse theatre that I've ever done. I did work on LIPA, which is the theatre school in Liverpool, but nothing really compares to this. It is a high profile project that has had exposure on a regional and national level. The scheme is linked to the wider regeneration of Prescott. A number of new restaurants and bars have opened in the area over the past 12 months on the back of the theatre going ahead. And I think confirmation of the scheme progressing was the catalyst for even more businesses opening in the area. It's just obviously such a downfall to COVID. Obviously all these new small independent businesses opened around January, just when we started like the main works, and unfortunately some of them have had to fold. So I'm hoping that once Shakespeare is up and running, these businesses will resume. There's some key facts. So here's a couple of CGIs. So the project value is 25 million. Client is with Knowsley Council. 106-week construction period, handover, hopefully, fingers crossed, January 2022. I say hopefully because we all know, being in the industry, that obstacles can come our way, things can get delayed. So far, so good. An interesting fact about Shakespeare is the concept architect is Nick Helm Architects. They're based in London. This scheme has actually been in his portfolio for about 20 years now, I believe. And it's only now it's actually coming to the surface. So he's still very much heavily involved in the scheme, in particular the externals. We've had a couple of, VE changes. Initially, at the top right-hand corner, you can see we've got like a bit of a sandstone clad, and that's actually now like a red pink brick. Still looks the part. It's that was approved for planning, thankfully. So the actual project architects who are overseeing the whole scheme is Austin Smith Lord. They actually did the Austin Smith Lord have got quite an impressive portfolio. One of my favourite buildings is in Liverpool. It's the Fact Cinema, like theatre gallery. They also did the Liverpool's Central Library, the refurb, which is pretty impressive. If you happen to be a bit bored, go onto Google and have a little look. It is pretty amazing when you go inside. Structural engineers, Mark McDonald. MEP engineers, Dog Group, and lastly, the stage engineering are Arup and Adlib. So the centerpiece, so what I'll do is, I'll try my best to kind of talk you through the floor plans, but what I'll do is I'll just scoot straight to the first floor. We'll talk about the theatre because that is the most interesting centerpiece of the theme. It's actually a recreation of a Jacobean theatre, very similar to the San Wanamaker. It's in fact, so it's an oak framed structure sited within a reinforced concrete box. Now, a specialist subcontractor, McCurdy & Co, have been employed by Knowsley Council to design this frame and fabricate the oak, which is an 18-month process. So Kier will then employ McCurdy to deliver the frame on site, the same subcontractor who did the frame in the San Wanamaker Playhouse in London, which is part of the Globe Theatre. And it's the only subcontractor in the country with the experience and expertise to deliver these works. So his name's Peter McCurdy. He's an interesting guy. He travels over to Brazil. He travels all over the world to find the best oak. So I wish I could show you and actually physically point, but you might be able, where it just says stage on the screen, you can make out the concrete octagon shape. So that is the actual theatre itself. All the kind of little bits in the corners there, obviously, the circulation points, the sound lock zones. So just going to if I just go back to the ground floor, this is the main entrance. I've tried my best to annotate it as best as I can, obviously, with it being a Teams presentation. So you come into the main entrance there. This is the main foyer. We have a feature stair. If you head towards the back of the site, you might be able to make out there's a bit of a ramp that takes you into the exhibition space. And at the back of house here, this will be the green room, dressing rooms, plant areas, and there's actually a bar cafe area as well, just on the right hand side of the foyer. So we've gone through the first floor theatre. Going up, this octagon theatre rises up into the second and third floor, and then into the attic technical level. So this is just a Revit model produced by Auditoria. Sorry, not Auditoria. So this is the Jacobean timber frame. Now, those of you who have seen San Wanamaker, you'll be able to recognise, obviously, the same characteristics. Now, one of the complications of actually having this frame is that, it's a new building. We all love M&E. We all need M&E. And with it being a traditional frame, obviously back back then in that period of time, you didn't have M&E, so we're having to kind of combine both traditional methods and brand new methods of design, coordination and everything. So we're having to weave in the M&E where we can, but obviously make sure it's hidden, because we don't want to be seeing big ducts, you know, through the ceiling, you know, through the the stage area. You know, everything has to be as traditional as possible. And another thing that was also affected was acoustics, because they don't want to have performances and potentially hear maybe a police car drive past, or, you know, everything has to be undisturbed as it was back then in the Shakespeare days. So this is just the CGI showing you exactly. So this is all going to be candlelit. So other features of the building are the reinforced concrete frame, which is quite bespoke in its design and very so I thought I'd pull up a little a picture of the Sam Wanna Maker, just in case some of you have not actually seen it for yourselves, but you can just see how impressive this is internally. So so internally there is a combination of exposed concrete and some high-end wall and floor finishes. So we've got a lot of walnut stair nosings, which again, something that you don't really have on many schemes. And I think the beauty of this scheme is that it's a traditional job. So a lot, as some of you may know, a D&B, you have a huge VE period. We did with Shakespeare, but not as intense as normally a D&B scheme would have. So, you know, we do have some amazing finishes in this project. So internally, as I say, there's a combination of exposed concrete with some stringent acoustic requirements, and there's also an external performance space which has been funded by Ken Dodd's widow, so Lady Dodd. This is actually an open air theatre, which is lovely. It actually looks like a bit of a piano from this view, but we've actually got like LED lighting in between the stair treads. So, and this is to the rear of the site. It's very small, and if you visit site, it's actually a really very small piece, but very, very significant part of the project. So this is a video from site. I hope this works. So you might be able to see here, this is the octagon shape. So here is you actually come up. So if I could just keep that on pause. You come up these stairs from the ground floor, sorry. Yeah. So you come up from this level, these are the pit passage stairs, and this is actually going to be a stage area, but we've also got temporary seating in here as well, which can be removed. And there will be seating. I'm showing you with my hands, but you obviously can't see. I'll try and see if I can do it with the cursor. So we've got seating around here, which is designed by Auditoria Services. Again, with M&E weaved in and around the chairs, so you just can't see anything. Thankfully, nothing is exposed. So just a quick view, just showing you exactly where where the video is taken. So you come up where I've highlighted here. So I think this is for the next video actually. So the video will show you a view of walking up these stairs and you coming up into the stage area. So this is where the performers will actually walk through. And there's one on the opposite side, so you will both come up at the same time, depending on what the performance is. And this can also be used for the audience as well, depending on how we want to rearrange the scenery and the stage itself. As you can see here, we've got here where we've got the exposed concrete, that is staying exactly how it is. Yeah. Okay. So I'll just quickly just talk very briefly just about the procurement route. So one of the challenges of the construct only procurement route is that the design team are working directly for the employer under a traditional arrangement, meaning our influence over them is limited. Being so used to working on a design and build scheme personally in my career since being in the industry, it's been an interesting experience as a design manager on the scheme. I am very fortunate in my short time that I've been with Kier is that I've been exposed to now both a D&B and a traditional, and I think both of them come with the advantages and disadvantages. I think the advantage to this is that we've got such a, as I've said before, such a high end scheme that we get to play around with, you know, really amazing finishes, and overall it's just going to be a huge legacy to leave behind. So that's it really from me. We have completed, we're on with it. So we've pretty much finished the concrete frame. So as the videos that were part of the site progress, they are where we are at the moment, just to give you that kind of overview of our stage. Everything is to programme. So far so good, but everything's going really well. We've not really had a huge, COVID's not exactly had a huge impact for us, fortunately, because we were very early stages of the project. We've had a couple of weather technical difficulties where we've had like high winds and things. We've obviously had to stop the crane. But other than that, we have been pretty lucky with Shakespeare so far. So far so good, I'd say. So that's it from me, guys. I hope you found it interesting.
Wonderful. We appreciate that, Natalie, and I appreciate you joining us, obviously, on your holiday.
No worries.
That's what, yeah. So obviously just finished at the end, obviously, with time, really. Obviously, if there's any questions, really, of any of the projects, or if anyone who's attended, yeah, you can send emails over to us, and we'll try and get answers for you, really. But obviously, from us, from G4C, really, myself and all the committee members, we're very grateful for the speakers. So thank you from Wates, obviously Peter and Jamie, for talking about their projects at St Helens, and then also thank you, and obviously Natalie from Kier's talking about your project there. Obviously, hopefully this has shown obviously some of the projects that are going on in the Northwest, and also we've got another 2 weeks of these webinars that we're going to do. Next week is going to be a webinar where we talk about the HS2 works that are going on, and then the Transpennine route upgrade works. Obviously we speak about them, and obviously it's a totally different projects, obviously the ones we talked about today. So hopefully many of you can join that as well. Obviously you go through our social media platforms like G4C Northwest on Twitter and on LinkedIn. Obviously go to the Eventbrite page and obviously sign up, and obviously it'll be free and everything again, and hopefully we can see you all again. So appreciate all your time, and hopefully see you soon. And obviously final note, obviously as an organisation we're always here trying to promote obviously the next generation, and obviously try and promote obviously our industry as a whole, to try and bring people into it. So myself, obviously I've wrote blogs, and we've obviously done webinars and events and stuff like this. If any of you need any help to talk about apprenticeships or obviously our experience, is always happy to help. So obviously we're grateful for the help that you're doing, trying to help us out as organisations. We're always there to help you out. So thank you, and hope you all take care.
Thank you.